Okay, so to everybody that's on the meeting, obviously you all know me. I'm Francis Nepveu, account manager here at NSS Canada. Today I'm going to be presenting about the new TS60 and MS60. So let's begin. Oops. Okay. So what's new with the new MS60 and the new TS60? What's still the same? Let's start off with. Why aren't we calling this a new TS70 or an MS70 instead? Well, Leica's pretty much gone and done the same thing that all the automobile manufacturers are doing. You got your 2020 Ford F-150, and then the next year's model is going to be the 2021 Ford F-150, right? So basically, Leica's doing the same thing. If it ain't broke, don't fix it. The MS60, even the old one from 5 years ago, is still one of the top total stations that are on the market right now. This new model is even better now. So physically, nothing's changed. If you were to put the old MS60 or TS60 next to the new models, they would look exactly the same. The only way you'd be able to tell them apart from each other is by looking either at the article number, which is hidden underneath the battery cover, or by going through the menus on Captivate. Eventually, you'd figure it out. Otherwise, Captivate is still running on board on the old and the new. It's just that on the new version, we have version 5 of Captivate that's running on them. Let's look at what has changed on both total stations. So on the TS60, dynamic lock has been introduced, or actually dynamic lock's always been on these instruments since 2015. I think that Leica was just looking for a third bullet point for the TS60. For those who don't know, dynamic lock is basically just the ability for the total station to lock back onto a prism while you're moving around, right? You don't have to stand still in order for your prism or your total station to lock to your prism while you're, going about your day. The TS60 also has a new minimum measurement distance of 0.9 as compared to 0.5. So for some people, this might be pretty handy. And then the Autohide feature has also been added to the new TS60 and the new MS60. This was introduced in 2018 when Leica released their new FlexLine lineup of total stations. For the MS60, which is basically what we're going to be focusing on during the course of this presentation, the new MS60 has got increased versatility, it's got increased speed, and it also has the new Autohide feature. When it comes to versatility, the increased, increased versatility, sorry, my things are out of order there, but we have a new band scanning method. We're able to stop and restart scans. We're able to reuse scan definitions, and then we're able to copy scan definitions from one job to another or an instrument to another instrument. When it comes to speed, the new MS60 has improved software and electronics. It's able to measure up to 30,000 points per second now. And then we're also using spiral scan patterns to optimize how we're taking our scans to speed things up. And then obviously just the Autohide feature, you press one button and then you automatically measure the height of your instrument. And then another thing that Leica's introduced, which is available for this line of instruments, is the LOC8, which is a theft deterrence and location solution. It was available again with the Flex lineup. Now it is available for the new TS60 and MS60, and it's basically just a way to track down your instrument in the case that, in case it does get stolen or something like that. So let's see how versatile the new MS60 is. There's a lot of people that could benefit from using the MS60. Let's look at a few examples and some use case scenarios. So for historical records or architectural preservation, this could be a pretty handy instrument. The new MS60, it could be used to scan significant historical or architectural objects or buildings. The increased scan range of the MS60 compared to any other Leica scanner other than P50 can allow the MS50 to be used in many more situations. And on top of taking scans, we're able to take topo shots and stuff like that. And use other total station workflows in order to do our historical records and preservation. Could also be useful in a scenario where we have a landslide or a fall of ground. After a large landslide or a fall of ground in an underground mine, the user could scan from somewhere where it's safe to do so. That way they're not exposing themselves to any dangers. The the MS60 has a reflectorless range of up to 2,000 meters, right? So we're able to take some shots from, a very safe distance. The MTO could be somebody that could utilize this feature in any kind of road construction, or anywhere where there's been some damage to the roads. I think that last spring we had some floodings in a ton of roads. An example that I've personally witnessed was the Highway 20 extension in Quebec. There was a very big landslide, and we were on site. We were able to take some scans and provide some data right away. Ontario Health and Safety or Mine Rescue could also use the MS60 as a CMS instrument. We could push it in around the corner into a heading where there was a fall of ground and take a scan just to paint a picture of what's happened, and make a plan of attack for rescuing people if they're stuck there still. In tunneling, construction, and underground mining, it could be also a very useful tool. The onboard Captivate software is a very robust tunneling application, which can be used in civil and construction applications. We can use it to monitor and check the alignment of the construction of a tunnel, pretty much. There's also third-party software such as MOS, the Miner Operated Service System, which allows miners to mine within design specifications, and this is compatible with the MS60 and other robotic Leica total stations. There's a lot of our mining clients right now that are using the MS60. This includes Vale, Glencore, Newmont, and a couple other mining customers. Other customers that could benefit from using this would be, for example, Hydro-Quebec. When they're building hydroelectric dams, they're cutting tunnels through cliffs in order to channel the water and house their turbines, right? So this could be very useful for, during the construction of those tunnels. We can also use it to in the shotcreting application. So anytime we're spraying shotcrete, it's an expensive business, and it's hard to determine the amount of shotcrete that's been sprayed on a surface or on a wall in an underground mine. So using the Inspect Surface app, we're able to scan before and after, and we're able to compare the two surfaces in order to see what the thickness is. See if there's some spots where we need some more, or if there's too much in other spots, and then we can notify the crews that are shotcreting right away. That way we're being proactive as opposed to being reactive. For quality assurance of prefabricated concrete units, so these units can be very expensive to manufacture. Before we deliver to site, or when we do actually receive it on site, we're able to scan that prefabricated unit, and then we're able to compare it to a DXF of it, just to do the quality assurance, right? So the manufacturer can do quality assurance, and the construction company that's receiving these things can also do their own. And this would be using the Inspect Surfaces app again. There's actually a company down south, Monteith and Sutherland. They're an Ontario land surveyor, and they were telling me about a story like that, where they used it on the Gardiner Expressway kind of thing. So that was pretty neat. Floor flatnesses, again, using the Inspect Surfaces app. So on construction sites, when it's critical to get the concrete floor as flat as possible, especially on big pads for big factories and stuff like that, the MS60 can come in pretty handy. Again, we're just going to take a scan, and then we're going to use the Inspect Surfaces app in the field to notify the crews where there's some high spots and low spots on our slab. During remote monitoring, so this would be utilizing geomoss in this case. Any kind of structure that's built on unstable ground can be continuously monitored for displacement, either by measuring individual points or by scanning that structure. The same applies when we're monitoring the movement of pit walls in open pit mines, right? So we're accomplishing this basically by mounting either an MS or a TS60 or a TM50 nearby the structure that we're trying to monitor, and this is going to be like a permanent emplacement that the instrument is going to be set up in. There's a lot of open pit mines that are using this right now. Victor Mine, Hollinger Pit, Fruit and Stobie, they all have these systems in place to monitor the pit walls to make sure that there's not going to be a failure. Civil engineering and construction companies, they use it to monitor bridges and their footings when they're during and after construction, stuff like that. For deformation checks, this is again another application for the GeoMOS and for Leica total stations as well. Throughout the excavation of a new high-rise building, we can monitor the retaining walls that are meant to keep other buildings from falling in, and check those out for any movement or deformation. Another company that could probably benefit from this is anybody that has a hydroelectric dam. We're able to place either prisms or scan the surface of the dam, look for deformations or anything like that, just to make sure that it's not going to be bulging in a spot or another. So as you can see, it's a pretty versatile instrument. It can be used in a lot of other applications. And then I didn't mention any of the actual just regular survey, boundary surveys and all that stuff. But for now, let's look at the many different ways that the new MS60 is faster than the old one. So the old MS60 was able to scan up to 1,000 points per second. The new one, on the other hand, is able to scan up to 30,000 points per second. So it's about 30 times faster than the old total station. This is all thanks to the new faster electronics that are on board and the improved software. So the faster electronics, the new MS60's electronics allowed it to turn 360 degrees per second, as opposed to the old MS60's 180 degrees per second. So just it turning around is twice as fast now. When it comes to improved software, so the new MS60 can now perform spiral scan patterns, as opposed to the old MS60, which could only perform a vertical scan pattern. So this basically just allows the MS60 to spin horizontally and then slowly increment the vertical angle of the scope as it's measuring its point clouds. Another added benefit to this would be that beforehand, when we were using the vertical scan patterns, points would tend to crowd close to the instrument. This would be a good example right here. With the spiral scan pattern, we're able to space out those points, and we just get a better looking point cloud in the end, kind of thing. More consistent throughout. One thing we do have to note, though, is like if you look in the data sheet, you're probably going to get confused because it gives you a scan rate and it gives you a max scan speed. So basically the difference is that the scan rate just says that the laser is pulsing about 30,000 times per second. Doesn't necessarily mean that we're going to be getting the 30,000 points measured in what time. This could be caused by low albedo of a surface, just like a very poor reflectivity, or sometimes we'll get outliers or mixed pixels, which are going to get filtered out. So we're probably looking closer to 24,000 points per second measured at any time. So we have new and improved scan methods. There's a new band scan method. What the band scan method does is it allows you to measure, to delimit or to define the upper and the lower vertical limits of a scan definition. That way we're just getting a narrow band or a very wide band, depending on your preference. This new scanning method could be pretty handy if we're inside a building and we're just looking to, get a floor plan. We're able to scan a narrow band and then, just digitize on top of that point cloud that we get from it. We have improved full dome scans. The new full dome scans, they utilize the spiral scan pattern now, so it speeds it up quite significantly. And then looking at the speed for the full dome scans here, so at 55 millimeters, spacing at 50 meters, with the old MS60, it would take up to 6 hours almost. Meanwhile, with the new MS60, it's going to take you only 40 minutes, so under an hour. So we're saving about 4 hours of work here, which is pretty sweet. When it comes to band scans, using a vertical scan pattern, the old MS60 is going to take up to 42 minutes to scan a band that's about a degree in width. With the new MS60, it's going to take only 30 seconds. So you're saving 41 minutes and 30 seconds, which is pretty significant. We also have improved polygonal scans. So any situation where you're scanning something that's above the instrument, you're going to get the option now to either include everything that's above your definition or below. So if you say yes, it's just going to do a full dome cap and use the spiral scan pattern. If you say no, it's going to include everything below your definition and then use a vertical scan pattern. So we got to improve the functionality while we're scanning. One of the new features is that we're able to stop and restart scans in the middle of a job. Say you're, getting kicked off site or something like that because it's, time to go eat. You can pause or stop the scan and then come back, reset up your total station, and then resume that scan where you left off, right? You don't have to, complete the scan. It's not critical to finish it, or you don't have to start from scratch the next day when you come back, kind of thing. We're also able to reuse old scan definitions. So basically setting up like a parameter that, your favorite parameters for a certain scan definition, we're able to store those in the job and then reuse them, as opposed to having to recreate all those definitions every time we want to, have another scan. So I could create a scan definition and then reuse it to do multiple scans. This could get pretty handy. Say we're, again, working in a building and we're trying to get a floor plan. Instead of me creating a scan definition for every room, I would just reuse the same definition and then just set up and then start scanning right away. We're also able to define the order of the scans now. So beforehand, what we had to do is we had to create all our scan definitions in the order that we intended them to be scanned in. Now we can create them in whatever order and then reorganize it afterwards. So a little more flexibility. And then, I mean, the new MS60 isn't going to be faster across the board in comparisons to the old MS60. There's still some scenarios where you're going to be getting about the same scan time. Here we have two scenarios where we have the facade of a building that's very far away, and then we have the facade of a building that's very close. So both instruments here are going to be using the vertical scan pattern. We can't utilize the spiral scan pattern in these cases. So when it comes to the building that's close up, the old MS60 is going to take 42 minutes, and the new MS60, thanks to the faster electronics, it's only going to get an advantage of about 10 minutes. But when we go and scan this building that's really far away, we're going to lose that advantage just because both instruments have to reduce their scan rates in order to be able to scan at that distance, right? So both instruments are going to take the same amount of time in this kind of scenario over here. So like as I mentioned, we have to reduce the scan rate when we're scanning at a further distance, right? So you're going to get the maximum 30,000 points per second at 60 meters or lower. As we go further away, the scan rate has to be reduced in order for the instrument to be actually able to measure points. And then we're still able to scan up to 1,000 meters away, but only at a 1 point per second kind of thing. And then all these values were measured by using like a Kodak gray card, so which is a surface that's 90% reflective. So at these distances or at this scan rate, we're going to be getting a point cloud that's similar to a BLK 360. As we reduce the scan rate, we're able to get a point cloud that's more akin to an RTC 360, so a much nicer looking point cloud, more accurate, right? So we do have some added versatility with this instrument. We're able to turn down, even though we're below the 60 meters, we can still turn down the scan rate to get a much nicer looking point cloud if you require that. Anytime we're remotely operating the new MS60, we're going to be capped at 80,000 points per second. This isn't because the total station can't do it. It's just because either the limit of data that can be transferred through Bluetooth and wireless LAN is limited, right? So I'm assuming that if you were to use this setup for like a monitoring station or something like that, you'd be tethered to a computer using a cable. So that bottleneck should be eliminated. So I'm assuming that you'd be able to scan at the 30,000 points per second if you're using this with GeoMOS or something like that. So we talked about how much faster the new MS60 is compared to the old. Now let's look at another feature that speeds things up, which is the Autohide feature. What is the Autohide feature? So this feature was introduced in 2018 on the FlexLine lineup. So the TS03, TS07, and the TS10. And then these were added to the new TS60 and MS60 in 2020, this February. So what this does is it basically just gives you the ability to measure your instrument height with a single button press. They have a built-in laser distance meter built into the bottom of the instrument. How you would use it is in the setup app. This works for any of the setup methods, by the way. You can use it for the resection, setup orientation, on backside, does not matter. In your setup menu, you would press the F4 key, which is measure height. And then you would get this page right here, and you just have to press distance, and it'll measure the height automatically. From there, yeah, you just press OK, and then carry on with your setup. Certain things to know, right? There's some incompatibility with certain tribracks. So if we have a tribrack that has an optical plummet, obviously that's going to be getting in the way of the laser. The way the Autohide works is it's a laser that needs to pass through the tribrack and the central fixing screw of the tripod, right? So if there's an optical plummet there in the way, it's not going to work. Or in this case right here, if we have the foot screws that are cranked all the way to one direction, there's a chance that the central fixing screw of the tripod is going to interfere with that laser, so we're not going to be able to use this feature. This has been addressed by Leica, so they actually created a new central fixing screw that's much bigger on the bottom. That way, you know, even if the foot screws are cranked, the lasers are going to be able to pass through. And you can order this new central fixing screw to retrofit your old Leica tripods, or any new Leica tripod that's coming out now is going to already have that central fixing screw. Certain surfaces do and don't work with this feature, right? So any surface such as common ground markers such as steel or brass nails, plastic stakes, wooden stakes, or boundary stones, or just solid ground surfaces like asphalt, concrete, curbstone, cobblestone, sheet metal, laminate, vinyl floors, short grass, you know, all those surfaces are going to function when you're using the Autohide feature. Some surfaces that won't work at all is surfaces that are, you know, 4% reflective. So basically a surface that's pitch black. Any kind of soft or fringe surface, such as a carpet or a velvet surface, is not going to work either. And then any kind of points that are underwater, underneath a puddle or something like that, those are, you know, the laser is going to get absorbed by the water, so you're not going to get a return, and you're not going to be able to get a measurement. Another thing to keep in mind is that the Autohide feature measures to where the laser spot hits the ground, right? So you want to make sure that you're not measuring that the laser isn't split on the edge of an object, kind of thing. And then the range for this feature is between 0.7 meters and 2.7 meters, so pretty high up, like this guy's got set up on his tripod. There's a lot of benefits to using the Autohide feature. Obviously, time savings is, you know, one of the key features. Using the Autohide, we're going to be saving about 30 seconds per setup. Doesn't sound like a lot, but assuming that you're setting up the instrument 10 times per job or often, then you could be saving up to, you know, 5 minutes or whatever. Again, that doesn't sound like a lot of time that you're saving, but in addition to that, you're reducing a lot of the stress, and you're removing a lot of the human error that comes with measuring your instrument height conventionally, right? You don't have to get a tape out, you don't have to bend down, you don't have to, you know, try to mess around with hooking the tape to the bottom of your foot. You don't have to do any of the measuring actually, and then you don't have to punch in any of that data. You just press the button, and in 3 seconds and you're done. It's a pretty accurate laser distance meter, so it's accurate to within a millimeter. Using a tape, you know, you could be as inaccurate as 5 millimeters, right? So again, already much more accurate than conventional methods. Like I mentioned, we're eliminating a lot of the human error, right? So, or we're reducing some of the mistakes that you know, you can't really control. Things like, you know, the end of the tape not being correctly placed on the ground marker, the wind blowing around your tape, you know, the tape measure, you're not going to misread it. In a case like this, you know, this is kind of hard to read. We have 161, you know, this could either be a 7 or an 8, right? So a millimeter discrepancy right off the bat. I don't have to mess around by having to measure that stuff. You know, with the Autohide feature, it's pretty great. There's also less equipment that we have to bring around, right? So we don't have to bring a tape. There's no chance of us, you know, either forgetting our tape, losing it, or breaking it. The Autohide feature is built into the instrument, so the only way that you have the same problems is if you forget or lose or break your total station. But at that point, you're going to have a much bigger problem anyway. So just a few more things to clear up. We're just going to do a bit of housekeeping here. The new TS60 and MS60, they're going to have all new article numbers. CCPs are going to be the exact same for the old MS60 and the new MS60 and TS60s. Accessories, sorry, I kind of skipped over that one, but accessories, there's not going to be any new accessories coming out for the new MS60 and TS60. All the old accessories are going to work on the new one, the new instruments, and vice versa, right? So you can continue using your old accessories. When it comes to upgrading your old MS60 to a new MS60, that is not possible. Reason being is because there's all new electronics and a bit of new software kind of thing. You would have to completely retrofit your old total station in order to upgrade it kind of thing, or just get a new total station, not unlike the P30 and P50 kind of thing. Captivate, with the release of the new total stations, we're also releasing version 5 of Captivate. These two total stations are going to have to use version 5 or higher. You're not going to be able to reverse the firmware and go back to an older version. And then when it comes to remote operability, so using either a CS20 or CS35, you're going to have to make sure that those have matching firmwares in order for them to function together. So that means you're going to have to update the CCPs on those devices in order for them to continue working. So before we move on to questions, we do have an upcoming webinar on the 29th of April, presented by Victor Valdez. It's going to be on the building of smart mines of the future. It's basically just an overview of the Hexagon Mining portfolio and all their cool products that they have. So tune in for that next week. And then now that I'm done talking, I guess I'll open things up for questions. So if anybody's got some questions, feel free to unmute yourself and go right ahead. Otherwise, there is a chat, so you can type in your questions there. Where is it?
Hey, Frank, this is Marty. Would you happen to know if there's a significant price increase between the two instruments?
Same price.
Perfect, thank you.
Yeah. I do have some questions that I was asked previously. So again, the price is the same with this new total station. You're not gonna be paying an extra arm and a leg for this new one. When it comes to maintenance, someone had asked, like, how long is this new instrument gonna be supported? Usually, like any instrument that they release, they'll keep parts for an additional 10 years after the product was discontinued. So the lifespan of this instrument is going to be at least 15 years or more as of now. We're still using the same top loaded case as the old MS60. And then when it comes to panoramic image speeds, when we're taking a scan, that performance is going to be the exact same. They weren't able to speed up how quickly it takes pictures. So it's just the scans that are much quicker. Not sure if anybody else has any other questions. Okay, so I guess that's it. Thanks
Well
again.
done, Frank. Thank you.